So today we're going to review systems of equations and what those systems look like in graphs and what they would look like with the actual equations, depending on the number of solutions that they have. So let's start with one solution. A system of equations has one solution if they intersect. That intersection is their solution. So in this case, this intersection is at -1, -3. So that's the solution of this equation. So if we were to solve this system of equations here, we would end up finding that x is equal to -1 and y is equal to -3. Now, what makes this set of equations have only one solution? Like, how could I look at this set of equations and know? Well, the slope is different. So when the slope is different, automatically we know that they're going to end up intersecting. The y-intercept could be the same, but if it was, then that would be the point of intersection. So that would be the solution to the equations. So let's take a look at the next systems. So no solution. Why is there no solution? Because we have parallel lines that are never going to intersect. How do they become parallel? They have the same slope. So as soon as the slope is the same, and then they have a different y-intercept, they're going to be parallel to each other and never intersect. And then finally, we have our infinite solutions. So over here, infinite solutions, it looks like we just have one line. And the reason it looks like we just have one line is because the equations end up being exactly the same thing. So these have to be the same equation. And sometimes you'll find that you have to use distributive property or combine like terms or do something to one side of the equation or one of the equations. But when you get them into the same format, you'll realize that they're the same thing.